I can officially say welcome everybody to the February MaxMSP meetup. Today or this month is hosted by yours truly, and this month we are focusing on sonification. As I have said, normally we would have 3 presentations today. Unfortunately, Ankit Malik is sick, so he won't be able to present maybe for one of the next months, but still we got 2 awesome presenters for you all today and a bit of time afterwards for those of you who are live to chat with these people. And this month's topic is on sonification, which has been a very popular topic lately, at least in the music hackspace community. And just to briefly introduce the idea, well, it's about sonifying things, right? So it's about taking data about sound, about extra musical things, about, I don't know, data, about CVS files, anything, and turning it into sound and music and trying to apply that either creatively or from a design perspective. So Joost van Kerkhove is a composer, improvisator, and pianist. He combines freelance composing with teaching improvisation, piano, and composition. And he's also my very good colleague, a professor for improvisation and music theory at the Royal Conservatory of Antwerp in sunny Belgium. So Joost's presentation is entitled Sonifying Birdsong, where he uses multiple external libraries such as Bach, Cage, and Dada, with various modules in MaxMSP that seeks to bridge symbolic and concrete representations of music and sound. And this offers new ways to interact with complex structures. And in this example he's going to show, he will be using a fragment of bird sounds to experiment with different ways to sonify and develop the sound's inner structures. What this exactly means, I leave to Joost. So there you go, Joost. The floor is yours.
Thanks, Umut. Thanks for the lovely introduction. So I'll share my screen. So I sort of want to start off with mentioning that I consider this sort of to be a bit meta sonification, since it's not one concrete example or a few raw examples rather of sonifying stuff, but rather a focus on how the Bach and Cage and Dada libraries help me to bridge the worlds of data and concrete data, sound data, other data, to a more musical notation, actually. And so in where they can actually interact between one another. So the external data can generate scores, and the scores then again can generate parameters or frequencies or whatever. Voila. And so I prepared a few little examples just to show you how I use Bach, how I come from external data to sound information or to score information, how I am developing stuff to treat that, to change it, to manipulate it, and then also how I apply it actually in the context of classical composition, of acoustic composition. Voila. So I don't know, does everybody know, did everybody know or has ever heard from the Bach and Cage libraries?
Maybe you can quickly introduce it.
Yeah, so just to know that the Bach and Cage and Dada project is a project which originated about 10 years now ago in IRCAM. It's written by 2 Italian guys, Daniele Gysi and Andrea Agostini. And there is actually a whole website. I will talk about this nice picture a bit later. Voila. So basically it are 3 packages in Max. One is a sort of basic package, is Bach, which contains different editors. It's really huge, but it's really super powerful as well. So it's a little bit like you have Mubu or you have Spot, the IRCAM. So these are packages that really are sort of world on its own. And so also for me, I got to know it around 2017, 18, and it took me about a year, 2 years to really get all the possibilities to really harvest the full power of the libraries. But I must say, it's the best thing that happened in my composition, in the technical aspect of my composition practice, because it allows for a complete, it allows you completely to make your own tools, composition tools, both in the traditional and in the more, let's say, contemporary electronic way. And so I actually became a Patreon for them. So I support them with a heavy amount of €2 a month. But that means that also through the Patreon, you have access to the ears package, which is extending all that information also to regular buffers. So to the use of max buffers, which allows you to do micro montage, to, for example, to combine macro montage with a score object and so on. Okay, so before I dive in the particulars of the data to the score and to the sounds, I quickly want to show the main thing that started to exist from my exploration of these packages. And this is a huge score editor, which is actually now my main editor for composition, and which allows me to do crazy things, things I'm not able to do neither in a DAW, neither in Sibelius or Dorico. And so it's through the bird song that I wanted to make a little example, but I can also already, I will make it a little bit, wait, let me move the zoom bar here. I will make it a bit bigger. So can you all see this? Yeah, all right. So they built in a few little, first of all, a few little things to work with the sound and with the pitch data. So if I paste this, for example, I can zoom out. Sorry. And I can start to manipulate this little bit by moving it like this, stretching it. So it's a much more making, for example, this little element legato. And so this became for me really the bridge between writing on paper and doing electronic experiments and making the final maquettes. And so one of the first, so I wrote a few pieces, and then I remembered that I had this little fragment of bird song. So what I did was make, wait, let me zoom again, was making a pitch tracking analysis. So I will show you the original files. Wait, okay, here we are. So I used to live a year in Mexico, actually, and so this is a recording of a bird that I made there, which I liked a lot. It was a bird that sat next to my sleeping room every morning, and so every morning I got the same tune to wake up. It was kind of my alarm clock at 6 a.m. in the morning. And so it, I don't know if you will be able to hear this now. All right. Voila. So it's just a little fragment. I clean it with Eric's from Isotope to get the noise out, because it was a phone recording of a very old phone from many years ago. And so from there, actually, I did a partial track with Spear, I think, which is a pretty common tool. And so you get a set of data, which is just pitches and durations. And then starts actually the work to start to translate this to the Bach library, which is not so difficult. I will show it afterwards, but I'm going to first play this. So this is a playback of purely sine tones. If I, let's see if I can open, if I can enlarge the patch a little bit. I don't know how clear my screen is, but so this is these are all subpatches for playback, and one of them is for sign playback, and you get this. Wait, sorry, need to put this here. Easy synth. And wait, probably. Let's see. So here I choose the instances of the sign synthesizer, and I hope it won't crash. No. So compared to the original, it's actually quite close. Voila. So but the big problem here is, how do you start working with pitch data like this? And so this is actually where I needed to look into more techniques that are coming from sonification and other kinds of things. Because in music theory, there is in traditional music theory, you don't really have a lot of tools to talk about this kind of blurbs, because it are like almost graphical spats on the score. And so in a certain way, I just started to manipulate them in a very free and intuitive way, which is actually still what I'm mostly doing with this material right now. It's going to be a piece, but so I just started to enlarge. Let's zoom out again. And to see how it sounded. So this would be the equivalent of having the recording spat down for like a very, very large amount. Okay, and so now in this final one, for example, you really start to hear that it is a gesture. Voila. So this is actually where I started to dive into theory, which I'm still sort of researching right now, because I'm still figuring out what to do with this material. It's going to be a piece with violin, this is for sure right now, but I don't know whether it will be acoustic or acoustic combined with electronics, or with only electronics next to the violin. But so from this gestural approach, this seemed the right way to proceed. So even slow down, you can still hear it. And so one of the first things, for example, I started to try out is to bring it in relation with another editor I made, or another part of the editor I made, which is the playback by the Contembre sample library. And this, for the people who don't know this is a special sample library made for contemporary, for experimental and contemporary music. And it contains, so it works like Contact or like any other sampler. And you can load in a huge amount of extended techniques. And it's also fully microtonal in playback. So for example, for the violin, these are all the possible playback techniques. It's a sample library with only solo instruments, but it is about 200 gigabytes of samples, so it's huge. So the idea was, the guy who made it had the idea that with this sample library, you should more or less be able to mock up a Lachenmann composition, a Lachenmann piece. So, and the good thing is that, for example, in one voice of the sampler, you can enter different instruments and different techniques. So what I did, for example, was to take a to take one of the modules I made in my editor, which applies a playing technique to a note in random. So I entered them here as words. These are all the playing techniques: Bartok pizzicato, pizzicato, con legno battuto. And whenever I click, I don't know if you can see it because it's very small, but I will paste it in the bigger maquette later. But whenever I click here to a random, it changes the playing technique. So I can make different, like, semi-improvised things. Sorry, just zooming. And so I actually, then I can save and I can load in the editor. And now I change the playbook from synthesizer, so from sine wave synthesizer to contimbre. I need to update my voices. And then I will put it also a bit slower. So you can see now all the, if I zoom in very deeply, you can actually see all the playing techniques per note. And so if I play back, you see here the sampling of the voila. So now if I take from the previous example, so this is another part of the editor I made, which are little snippets in order to enter information, to have little chunks of material. So if I open again the playback and I take this one that I recognize to be a gesture, which is, I think, in the end somewhere. Let's take this one. Sorry, those two. I think this one was it. And so I go to the same one. I paste it here. I transpose it a few octaves into violin range and then apply again the random. And so now I paste it back into the maquette. And so I stretch it. So this is actually becoming a super, super powerful tool. So you don't really hear the gesture again. So yeah, for example, here was one. Yeah, so you recognize it a little bit. Yeah. So for example, if I take this, and for example, I would, which I already did, but I saved it, and I would import it again, but now it's made so that it can play back to MIDI, which is actually here. So I put it on Piano Tech, which is a piano sampler. And again, I need to change the playback. Voila, and put this a little bit more quiet. Wait, and then ask it to play back from. Voila, you get again another example of how you could treat it. Let's transpose this down a little bit. GG, sorry. Voila. Wait, sorry, like this. Again, so now it's in middle piano range. So now you even hear the gesture more as a gesture, really. So of course there are like a lot of possibilities also to start thinning out all this information, to filter it. It's amazing how many modules actually the people from Bach already built in the library. But so as long as you know Max fairly well, you can start building your own stuff. And so one of the important things to start working with it, and this is then one of the first examples where it starts to be closer to really sonification, is the idea that you make it into a profile, into a BPF, a breakpoint function. And so the good thing so this is actually the same as the function, or in a certain way, this is the same as the functions object from Max, this one, which we all know, in which you can draw coordinates. The only nice thing is that actually for every of those objects, the guys from Bach made a sort of little library of 30 slots, which you can fill in with all the data you want. It can contain text, it can contain, so if I go to an empty one and I choose the nature of the slot, you get all different types of information that it can contain. And so now this is a very simple example. So then you need to start constructing, of course, modules to get this to play back. And so if I quickly go over this patch, it's not that difficult. It's just you need to start to learn to the Bach objects a little bit. But it takes basically all the information from the x-axis and the y-axis. And so where the x-axis would be the time, which in this case is an arbitrary amount of 5 seconds that I give it. And then the y-axis is, in this case, the frequency, which I say here arbitrarily, I multiply by 880. So it moves, so 1, the highest value would be 880. But again, this is a question of knowing a bit your mathematics. You can start being creative with this. And then it does the same thing for the amplitude. And so they both get the value of 5,000, but I can make it 8,000 seconds now. So I just put 8 and I multiply with 1,000. And then I say dump both these slot contents. And then, so now if I play back, normally you would have a simple sine wave in the cycle, and it would make a sort of instant crescendo, stay loud a little bit, then go down, and then go up again, and then fade away. Let's see. Voila. Okay, so that's a rather rudimentary example. Another thing, good thing or interesting thing is that also the notation objects are fully interactive. So I took a little stream from the from the bird song. Let me clear this lower object, and I ask it to loop, and it just plays back this looped part. And then while it plays back, I ask to change the pitch in a random way for more or less one whole tone. Yeah, so it will always play back the same thing. And let's maybe do quickly the same thing for the velocities. So this just means that I do the same thing. And now I don't multiply it with 1,000, of course, but I choose, let's say, let's say 20. So in order to really do this well, you would probably need to make this a little bit more, where you can either make it subtract or add. Now it's just adding, so it's I'm going to make the input soft enough. Wait. Why does it? Ah, yeah, sorry, because I'm not in. So so these are also little things that they put inside. And so now when I play this back, it will loop and it will choose random changes of the pitch and random changes of the velocity. And I still need to connect this here, of course. Let's see. And so I need to engage the transcription. Voila. So I get something which probably will resemble the gesture on top, but will be slightly different with different velocities. And so I say stop. And here also stop. And now I choose the whole thing and I say legato. So I can have it played back by my piano sound, for example. So I go here, go back to my editor. Let's move this here. And move it a bit out of the way. Okay, and let's make it a bit more loud and here as well. And so on. Voila. So like this, you can actually take data and then start to generate again new structures from that. So one of the next things I was thinking, okay, if I can do this with one BPF, one profile, why not try to do it with the different partials of a multiphonic. So I took a clarinet multiphonic, which I have conveniently here. And so it will calculate, and it's basically, so again, it's something which I've done with Spear, the spectral analysis tool. And so if you look at the raw data that is entered, this is just position in milliseconds, approximate partial frequency, approximate loudness, I think, and the last one I don't even remember. So this is a data set like you would get from any other, well, sonification material or something you would get from, you can use whatever data you want in this case. I just took the partials, and then I wanted a very specific thing. I wanted, so for every partial, if you look here, let me put it a little bit bigger, this one, sorry. No, yeah, so it should be a message. vzoom $1, and then I can enter the zoom. So let's put it instantly on 200. So if you notice, for every partial, all the data in the matrix corresponds with one tiny dot in the breakpoint line. In order to not make it separate nodes, which is a typical thing you get when you, for example, use it with do the spectral analysis with Open Music, for example, it will put all the separate little partials or partial changes in separate notes. And if you play it back, you get this kind of machine gun effect. And so I wanted to avoid that. And so instead of having separate notes, I wanted little inclinations in the breakpoint line. And this is another thing which makes the Bach notation object incredibly interesting. That is that you can actually have a note with a duration line, and then you can have a sort of like glissando, well, they call it a breakpoint line, a pitch profile from that note, which is actually kind of considered part of that note. And for example, this is also very interesting because a thing like this, I can also play back with contimbre, for example. So if I go back to a fresh template in contimbre, and I choose contimbre, playback here, and I update the voice names again, and I paste my little breakpoint note, and I can actually stretch that, and also the breakpoints get stretched. And so now I go to my sampler, and I say, please give me a oboe or a clarinet, just playing Flatterzunge, like this. Okay, so he, well, normally I should also name the technique, but I don't need that right now. I put it soft enough. And so when I play this back now, you will hear that it makes a glissando profile. So that means that also you can start working with quarter tones in a very, very, very precise way, and a very interesting. Voila. So you can
interrupt you.
Yeah,
you have about 5 minutes left.
Okay,
so
but I'm almost finished.
Yeah,
I'm almost finished. So this is the original multiphonic. If I play it back, I can actually also show you the recorded original. Sorry. So this is sound material, selected multiphonics, clarinet. I think if I remember, it's number 78, which is not, yeah, here. Oh, wait, name 78. Oh, yeah, so this is pretty loud. So this is the equivalent in spectral reduction or in spectral analysis. I already filtered it a little bit. And so now I can here, for example, start to scale the inner drift of every partial. So I can say, let's scale this up. He needs to recalculate. And because of zoom, that goes a bit smaller. And you start to see that there start to exist a tiny vibrato, a tiny, well, not vibrato, but a pitch, pitch modulation. So let's put it quite a lot higher. Let's recalculate. Still. Let's do like this, 800, and probably it will be very audible. And so now in theory, I can also just go back to my editor and then paste this here and give the clarinet its own multiphonic to play. But of course, there you need to start really working the material. So finally, just the last 2 minutes to wrap it up. I just looked at the website of Bach whether other people, because I'm not a lot into sonification in the true sense of the word, but I found a guy who was really creative with the Bach library. And I have no idea how this would sound, but I guess it will be very cool. But this is part of one of the, so if you go to the projects here, there are a lot of interesting projects, which some of them contain different forms of sonification, but there are other. I can also warmly recommend Moslip, which is a good friend of mine, Julien Vassenot, who is developing this, which brings actually all the libraries of open music into Max and fully Lisp coding. But some also some dynamic score projects, which is, I think, the thing that Bach is mostly used for. So let me check whether there was still one thing I wanted to show. Yeah. And so the final thing, so in itself, it also started to be a way to work in Max for Life. So this is the pure Max version. This is a synthesizer, Alto, which does West Coast synthesis. And normally this would be the part where you would sort of steer all the stuff, your sequencing part, but I cut that out and I replaced it with a complete Bach score. So with breakpoints, and so this could be maybe also very interesting. So I'll play this back a little bit. Voila. And so, yeah, this is giving results, which I don't know how I would do that in Sibelius. And so the great thing is that because all this is Max, of course, it conveniently builds, sorry, this was the wrong button. It conveniently builds into Max for Life. So I have all the, so I'm actually working right now, and this is one of the next stages, to integrate a lot of these materials into Live, so I can actually use it. And for example, one of the first elements is a sort of automation device for effects. So where I can have up until 20 automations visible. And so if I play this back, for example, you will see that the material and the decay parameters of the corpus device change. Voila. And so potentially like this, you could start to really bridge the world of score writing and electronic music. And this is something which for me is super interesting because I'm a very structural nerd. And I like my electronic music to be sort of in sync with what I like things to grow from a certain same score base and or same conceptual idea. And like this, this library, it allows me to do all the things that I can. I can't think of a certain thing that I can imagine in my head that I can't realize with this with the Bach. And but okay, like I said, it takes a while to. It's a bit of a learning curve. That's to say. So yeah, I think that's about it. I apologize if it was not enough about sonification, a little bit about just my own practice. I hope it was interesting in any case. And well, if you have questions, then I'm sure afterwards there will be time to discuss now. So I stop the sharing, Umut.
All right. Thank you, Joost. Yeah, it wasn't to me exactly about classical sonification, but I see a lot of applications there where you can really take the data from your spectral analysis and just map it into all these crazy parameters.
Yeah, since actually for me, sonification in a certain way is also always the arbitrary decision. You have a set of data which is not related to sound or not related instantly to music. you have to make some kind of arbitrary decision about how you relate the data world with the sound world. And I think the Bach libraries just allow for a lot more experiment than there used to be, or at least with some relation to traditional composing also.
Yeah, absolutely. So for questions, we are going to do that at the end of the meetup. So first, I'm going to let James present his presentation. And just as a reminder, afterwards, we are going to have breakout rooms for these two fantastic artists. So you can really go ask questions. There was a comment in the chat about the patch screen not being big enough, so it was a bit hard to read. So again, afterwards, it might be a good moment to kind of zoom in and look at the patch together if that is what you want to do. So to introduce you very quickly, James. James Wilkie is a sound artist and a composer who explores the connections between persons, spaces, and the imagination using sound through directed listening, audiovisual composition and installation work, text, and live performances. So a bunch of really, really nice words. He has worked with sensory experiences and Bentley Motors and has worked in film via remote control. He currently teaches at UCL Bartlett Designing for Performance and Interaction March as he continues to work in music and research. And James is going to present his Act 3, the prototype, which is apparently a part of a larger multi-sensory installation developed and exhibited at Lake Etenclave. Hope I'm pronouncing that right. Yeah. But the details, again, I'm going to leave to you, James. So the floor is yours.
Thank you, Matt, for the kind introduction. And yeah, it's nice to be back here and taking a turn to be able to share this. What I'm about to present is, as Umut was describing, is part of a larger work. It's a third act of 3 different sonification projects that manifested in a collaborative space called Lake, which is at Enclave in Deptford, if some of you are familiar in London. And this one involved, many of them were the idea of prototyping an idea and growing them into a multi-sensory exhibition. So this one, it was a photo book, which was then blown into an installation, which included architecture installation, which included immersive sound, and of course the photographic visuals, the elements of the piece. So this is the sound aspect of it, which was an important, the patch sort of binds the entire idea together through video, through sound. So I guess if I can start sharing a screen, I'll show some of the imagery and then move on to the patch and describe what is going on in the patch and so forth. So if I just, yeah, okay. I'm just going to share the desktop. What have I got going? So here, so this is Folium Publishing released a book called The Prototype. And it's based on a collaboration between 2 photographers who were sharing very grainy, noisy photos inspired from their own love of noise music. So to keep the spirit of this, the questioning of how do we translate this into sound, and I suppose the sonification, the data sonification aspect of this was, well, how do you keep faith with this idea of noise? So the go-to was, well, in some ways it's interesting bringing up Spear because I just used audaciously used Audacity to just make raw data out of the pages of the book, right? So we have these, if you can see here, these are all the single spreads of the photo book that were put through the installation. So we took every sheet, which I think there were 64 spreads in all. This is the visual aspect inspired from the imagery here that you can see. Hopefully it's large enough for everyone. I know that Zoom ends up making everything so small. And on one side, there's some frame photography. So these resulted, what's the most faithful way in reproducing noisy imagery? Make it in raw data, as I think a lot of us have experimented with, perhaps feeding images through Audacity is noisy. And it's data. So it's data visualization and sonification in this respect. And I think it's important for all of us to note that the answer isn't always max MSP. The answer can be Sibelius. The answer can be Spear. There can be some offboarding, offlining iterations before you get to max, and Audacity has its place as much as anything else. I have to remind myself of this all the time. So it started on Audacity like this. It produced these in themselves pretty images of data. Those are all then fed into, those are all saved as audio files. So I think we can bring ourselves to the patch now. So this is the patch. And so here you see, these are all these spreads. So there's actually, 63 spreads. So this is all nice, noisy spreads of data. And we thought, okay, how can we make this legitimately move around the space? Well, how can we make this, for me, a lot of my principle is about the avoidance of some kind of contrivance. There has to be a genuine idea of how things are going from one thing to the other. So how are the envelopes estimated? What's going to be a genuine way of moving these sounds around the space? What are they going to be triggered by? What's the architecture, the structure of the work? Because the more I'm doing this stuff, the more I hate things just end up being a drone, or it was the one. It's a lot of installations end up being as bad as the funk grooves, and people just doing widdly widdly wee over the guitar. So I'm trying to avoid this in respect of sound art. So how do we mitigate this issue and provide some sense of structure? Well, it happened that I don't have the video of this, but it happened that the two artists had put up this installation before somewhere else, and they had videoed themselves laughing, putting the magnets on, and the magnets were bing, bing, making lots of sound. So I thought, well, what if we use that in itself, of course, of videoing someone doing an act, performing an action, has a choreography to it, right? Why don't we use that duration, which is a 40-minute long video, extract the audio from that, and just, this is very simple. I really try to keep things, elements as simple to bring complexity together, because things get complicated quick in life. So here, this is the extraction of that video, just the audio. In fact, maybe, I don't know, I can't play it on the sound because everything's going to go bonkers, but can I? Do we hear anything at all? No, of course we don't. Why would things work so easily? So let me just put this straight through my duet. I think that will help us. Let's see. Sounds like we might have something going on now.
Did you select share computer audio when you were sharing your screen on Zoom?
Maybe not. Thank you, Emmett.
That's always the one.
Yeah, it is always the one. Okay, I'm going to go back to sharing the desktop. Do we hear anything at all? It's quite low, actually.
Maybe you have to switch back to the Zoom audio device now that you are sharing it.
Uh-huh.
Yes.
Oh, you are hearing something?
Yep.
Now? I don't hear anything on my side.
Me neither, but I see some people vibing with the music, so
I can
I
hear
guess very
very
low
low.
frequency.
It's very
Yeah.
low.
Yeah, I can. It's very low indeed.
Okay. I'm sorry for that. I'm not sure how I can get it louder. Because oh no. Don't I just need to?
Probably it's best to put on headphones because it's sort of a frequency that with bad speakers you might even not hear.
Do you hear it now?
I do. I do, yes.
Okay. It's really glitchy sounds. that. Yeah, I don't know if you could, there's normally a hum and sort of crackling of noise, if you heard some of that. So hopefully that's enough to help me continue to explain what's going on here. Yeah, can you hear me now? Yeah, okay, so that fixed video is being used, so any clamping and laughter and activity from the two artists is being used to trigger the peak amp, and the peak amp is acting as a gate to open up the sound of these spreads. These are here the spreads being moved around. And so what is a genuine way of moving these spreads around? Well, why not use noise to provide coordinates for the sounds? Why not use noise to provide the ADSR for the sounds? So why really use the spirit of noise for every aspect to create a genuine experience for this? So if I go into this, I was using CV.jit noise. So the JIT externals are really incredible, really, for a lot of work to do with visuals. And I recommend, yeah, you can tuck into these, because this is generating a classic, well, just instead of random, which is a bit not very random and not random enough, you don't get enough random values. Here with noise, the CV.jit noise, as you'd use for jitter and noise, you get a lot more interesting values. So with 3 of them, they're creating X, Y, Z, which really in this situation, we only need X and Y coordinates, but it gives you a spray enough that you can pack these in and so create the animation that we're observing here. So there are 7 points, because there were we had a 7 speaker array in space. So they're really moving freely. Each one then, you see here that are grouped, the spreads are grouped into sets of spreads, and each set represents a dot within this. It's ADSR, the coordinates are being used as much to create movement as they are to create an envelope to these drone sounds, because I really want to mitigate this idea of droning too much in these installation works. So you've got a sense of structure, although it's an ongoing installation. ADSR here. There is also video interaction. So there was a light. So it's only showing me now, but there was a threshold of light on the camera that was connecting the architecture, that L that you observed earlier. So that was reacting to sound as well and giving a thump on the subwoofer. So you had a connection, a believable connection between the noisy light, the sound reacting to the light. So the space and the sound and the idea of the book all being webbed together through sound. What else can I share with you here? Well, of course, there has to be some element of atmosphere. And so these 2 drones were used as, I just cross-convolved the spread sounds and had these orbit around the space, because the photographer had this idea of having one side of the room be quite sound brighter, lighter than a heavier part, another corner. So a heavier sound was used to orbit around the room, while a fixed lighter sound was staying in the corner. So you can see that, I think, in yeah, so this corner would have been brighter, and actually behind this wall, in fact, we had a subwoofer, which really made a huge difference to the immersity, the feeling of the room coming together like that. What else can I share on this? That's generally it, I believe. As an explanation, I mean, I hope it was a clear enough explanation. It's but that's the strivance I go for, is finding the believable connection between elements, and my work manifests itself physically a lot more than only a listening experience at the moment. I guess because I'm working at Bartlett now, I keep thinking about space a lot more and sound, so I have that opportunity. Yeah, I think that for me, that's all the bits of my patch.